Welcome back, everybody. Today we're going to talk about hypothesis testing for the mean when the standard deviation for the population is not known. All right, so in the last section, when we did hypothesis testing, the one common thread that we had, well, there were two things that we had that were common to all the problems that we practiced. The first one is that the standard deviation for the population was known. The second thing was that if the standard deviation for the population was not known, right, n was very large, was, let's say, greater than 30, all right, that way we could still use our z-test. All right, so now we're going to shift gears. All right, so in this new set of problems, we're going to talk about what to do if the standard deviation for the population is not known and our sample size is less than 30. All right, so if these two things occur, we cannot use z anymore, right? We don't have a big enough sample, and we don't have the standard deviation for the population, so we must use a t-test. Now, we've talked about a t-test before in confidence intervals. If you need more information on the t-test, you can go back to the confidence intervals video where I talked about the t-test. But let's talk about, all right, so let's review real quick just the formula. X, very similar to z, minus mu, over, instead of the standard deviation for the population, it's the standard deviation for the sample, divided by the square root of our sample size. All right, so other than this, to get our test value, there's not a whole lot of difference between what we did in 9.2 and what we're going to do in 9.3, except for the fact that you need to recognize which test to use when. All right, so in general, I'm going to talk strictly about using the traditional method, using those 5 steps to success. But first I want to practice with the t-chart once again, because there's a little extra that we're going to have with it. So let's try this example. Find the critical value for alpha equals 0.05 with 16 degrees of freedom and a right-tailed test. All right, so everyone get out your t-chart. If you need to hit pause, but let's get out our t-chart, all right? We're going to find 0.05, but notice it says one tail, two tail. All right, make sure you're 0.05 one tail, right? The right tail test is a one-tailed test. And then go down to 16 degrees of freedom, which is on the left. And the row and the column meet. And you should get a value, a t-value, right? Your critical value of 1.746. Again, different charts go out a different amount of decimal places. It is an estimate. So if yours goes out more, that's fine. If it goes out less, that's fine as well. But you should be hitting that value very close. All right. Here's the next example. Find the critical value for at alpha 0.01, degrees of freedom 22, left-tailed test. So we're going to find 0.01 in the row, in the one-tailed test row, and go down to 22 degrees of freedom. Now for my left-tailed test, I'm just going to draw this out real quick to illustrate what I mean. All right. All right. Left-tailed test is all the way over here, right? Typically 0 comes in and about the middle. So my critical value, which I'm looking for, is going to be negative. So the answer should be t equals negative 2.508, So again, right tail would be, here I'll use a different color. Right tail would be over here, right? And that would be a positive value. Left tail would be a negative value. All right, so just a little guideline to make sure that things are going okay. Won't guarantee that you're right, but it could stave off you being from guaranteed wrong. All right, so let's try one more. Find the critical value for alpha 0.10 with degrees of freedom equaling 18 for a two-tailed test. All right, so we're going to look for 1/10, alpha equals 1/10, in the two-tailed row now, and go across the left side for degrees of freedom to equal 18, and then the row and the column meet. Now remember, in a two-tailed test, again, I'm going to quickly draw it out just to show you what I mean. Right? We have a tail here and a tail here. So I'm going to have a negative value over here and a positive value over here. So if I'm asking you for the critical value, right, in this case, it's actually values. Right? So we're going to have positive 1.734, negative 1.734. And again, these charts, like I said, they go out different amounts of decimal places. If yours goes out less, that's fine. Yours goes out more. That's fine too. All right. Let's quickly review the 5 steps to success for hypothesis testing. So the first step, state the hypotheses. And identify the claim. Always step 1, always worth doing. You gotta write it down. Second step, find the critical values. And in this case, we're going to use the t-table. However, if the standard deviation for the population is known, you of course will use the z-table. Number 3, we're going to compute the test value. This is where you're going to use the formula t equals x bar minus mu over s divided by the square root of n in order to find your test value. Scroll up a little bit. Then we're going to make a decision. The decision is either to reject or not. Do not reject. Always HO, the null hypothesis. And then lastly, we're going to summarize our results. All right, that summary connects the problem to the context of the problem. I think it is very important, and it's something that I would like to see in any problem that I assign you. All right, remember, I will say it again, and I'm going to make a note of it here. Note, we'll write note. The t-test is only used when sigma is not known and n is less than 30. All right, that's very important, all right, because if you use the wrong test at any given time, you're going to get back a number, just the number could be wrong. I mean, you could get it right just by circumstance, but more likely than not, you will not get the answer correct or fully correct. All right, so let's jump into a couple of examples and let's see how this t-test is very, very similar to Z, and then we'll get you out of here. A medical investigation claims that the average number of infections per week at a hospital in Pennsylvania is 16.3. A random sample of 10 weeks had a mean number of 17.7 investigations. The sample standard deviation is 1.8. Is there enough evidence to reject the claim at alpha equals 0.05? All right, take a moment to write it down. Pause it if you need to. We're going to get started. Okay, so let's scroll up. And again, we're going to do our 5 steps. So the first step is state the hypotheses and identify the claim. So my null, remember, is that mu equals 16.3. And my alternative is that mu does not equal 16.3. And I'm going to identify this as the claim. All right, so number 2 is find the critical value. And in this case, values, because we have a two-tailed test. So it's two-tailed. Alpha equals 0.05. Degrees of freedom equals 9. So why don't you take a moment, pause it if you need to. Let's go to your chart and see if you can find the same critical values I did. All right, I got my critical values to equal 2.262. There's a 2 and negative 2.262. All right, and next we need to compute the test value. All right, so that's t equals 17.7 minus 16.3 over 1.8 divided by the square root of 10. So why don't you take a moment to do that? Pause it if you need to. I'll give you the answer on the back end. All right. I hope you got the same answer I did. I got 2.46. And again, I rounded to the hundredths because that's what's on my chart. All right. So number 4 is make a decision. Now, very often for number 4, all right, when I was in your chair, I'll just make a quick small thing. There's 2.262 and 2.46 is going to be a little bit after that in the rejection region. So the picture kind of helps me confirm that I'm supposed to reject my null hypothesis. All right. And then finally, I want to summarize the claim. I want to summarize the problem. And there is enough evidence to reject the claim that the average number of infections is 16.3. All right, so what we see here is that the steps stayed the same. Everything pretty much stayed the same, except when we needed a chart, we used the T chart instead of the Z chart. And we needed to take into account those degrees of freedom, as well as it is a one-tailed test or a two-tailed test. All right, so let's try one more example, and then we'll get you out of here. All right, an educator claims that the average salary of substitute teachers in school districts in Allegheny County, Pennsylvania, is less than $60 per day. A random sample of 8 school districts is selected, and the daily salaries are shown. Is there enough evidence to support the educator's claim at 0.10? All right, so for this problem, you definitely need some data. I will put in the data. 60, 56, 60, 55, 70, 55, 60, 55. All right, so there is your data that is shown. All right. So what we're going to do is I'm going to give you guys a minute. I'm going to put that back like that so you can pause the video if you need to write down the problem. And we'll start in just a minute. All right. So we're going to go and go through the 5 steps. First, step 1. State the hypotheses, identify the claim. So my HO is that the average is greater than or equal to 60, because my H1 is going to be that my average is less than 60, which is what the researcher is going to claim. All right, because, and number 2, we need to compute our critical value. All right, so all the components we have that alpha equals 0.10. We have our degrees of freedom because our sample size was 8, so that's 7. And it is, looking at our H1, a left tailed test. So let's take the one-tailed test. 0.10 and 7 degrees of freedom. Let's go to our T chart and find our critical value. All right, so our critical value, hopefully you found the same thing I did, negative 1.415. All right, so number 3, we have to find the test value. All right. So for the test value, the first thing I need is I need X bar and I need S. I'm going to scroll back down so you can see my data. And I'm going to ask you to pause it for just a minute and get me my average of the sample and my standard deviation of the sample. All right, so for my X bar, I got 58.9, and for my S, I got 5.1. All right, and the reason I need both of those is because both of those are included in my T formula. So I'm going to scroll back up, and my T formula is going to be 58.9 minus 60 over 5.1 divided by the square root of 8. And once again, I'm going to ask you to pause the video and do the calculation, and we'll talk on the back end. All right, so hopefully you got the same number I did, which was negative 0.6 1. All right, so now we need to make a decision. All right, so again, I like drawing a very quick picture. So my critical value was negative 1.415, but my test value, negative 0.61, is going to fall outside my critical region. So I'm going to not reject. All right. And lastly is the summary of the results. And since I rejected my null hypothesis, I can say there is not enough evidence to support the claim that the average salary of substitute teachers in Allegheny County, PA is less than $60. Oops, that's a terrible dollar sign. I'm going to make it better. $60 per day. All right, there's just a couple of problems on the t-test. Again, not very different from our z-test, except for the fact that of two things. Number one, standard deviation for the population is not known, and n is less than 30. We must use, right? There's our second thing. We must use our t-test in our t-table. All right, much more practice to do, but I hope I gave you a good start. Thank you for listening.